Today we are doing medium problem 516, longest palindromic subsequence. Given string S, find longest palindromic subsequence. S length is 1000, so we want quadratic dp. So my idea is longest palindromic subsequence. Let's say, I mean, if we have longest palindromic subsequence, basically you want to add 2 characters, so well, if we end in ij, which have to be same index, then we would have to either find a single character, right, which should work. So dpii is 1, dpij is 2 if I and j are, so si as j are equal. Otherwise, if they are not equal, it's 0, and if they are equal, then it's maximum of 2 and 2 plus and 4 all inside. But if I name all 0 that are not possible, right, then basically for some ij, because if we have a dp, right, and let's say I have like dp1 free or dp02, right, then I want to consider, or dp04, right, then I want to consider dp121 free, right. So it's basically I want to consider a prefix subsum of that. So I don't really want to do that, right? Yes, okay, I think I have the idea. So it's cache fdp. So need to pause. Anyways, we do dpij, right? And now if I is equal to j, we return 1. If I plus 1 is j, return si is equal to sj. 2 if that is the case, else 0, right? And otherwise, if si is equal to sj, we return dp I plus 1j minus 1 plus 2. So ans is max of dp I plus 1j and dp ij minus 1. So basically what that means is that let's pretend there is not match at substring ij, then we can either solve for this and answer and we ignore ith character, or solve for this and ignore jth character. And if this is the case, right, then if they are the same, then we also have one more option. And then we do just this and that should work. ONS. Okay. And we have like n squared states and we do O1 transitions. So that should pass easily. Palindromic subsequence. Yeah, this should work. Memory limit exceeded. How is it possible when S length is just 1000 and I exceed limit on last test case? That's a little ridiculous, don't you think? I mean, I could do tabular DP, but that might n is ln s. So for L, no, for I in range in -1, right? And now if Si is Sj, then dpij is equal to 2, right? And then for L in range 3, and then we do for I in range n minus L plus 1, and then we do like if so dpij max dpi plus 1j dpi j plus 1 dpij, and then if Si is Sj, then dpij max dpij dpi plus 1j minus 1 plus 2 return dp0 minus 1. J is I plus L minus 1. Because let's say if it's free, right, then it should be 0, 1, 2, and we do 0 plus 3 minus 1. That should work, I guess. Oh, because there should be minus 1 here. Okay, this should pass. If this doesn't pass, then I don't know, man. Okay, this works. But the fact that I got memory limit exceeded on that is absolutely insane. Anyways, dynamic programming n squared. And basically what we do is let dpij be the longest palindromic subsequence in substring sij approach. Base case, so answer dp0 and -1 where n len s. Base cases is dpii is equal to 1, dpi I plus 1 is equal to 1 if si plus 1, else dpii plus 1 substring length. Let's explain this. So substring length 1, longest possible longest palindromic subsequence has a length of 1. dpij 2 if they are equal. Okay. Technically I can delete this case, right? And dpij can be achieved by either skipping charakter dpi plus 1j or skipping jth character dpij minus 1 or skipping, or there is a match si sj and dpi plus 1 j minus 1 plus 2, right? And answer is this, n squared, since there is n squared states and we do one work per state, on squared, since we have this many states, right? We fill the table first, the base recurrence, we fill the table by first filling in the base cases and then by increasing substring length and starting index. Okay, it's kind of blur, but okay. Why not? Okay, DP problem. This is a not trivial 2D DP exercise, so see you tomorrow.